Hi friends, this is Kaushik, and today we have come up with a new mathematical chapter, rational versus irrational number, where we will explore different sets within the real number system. So, what is learning outcome? So, recall the set of numbers in the real number system, differentiate between rational, irrational numbers, and plot irrational numbers on number line. So, these are the points which we will learn after going through these sessions. So, I hope you will come with me. Okay, so first of all, just check this group of numbers. So this is a group of numbers. You need to check and tell me, can you segregate these numbers into two groups? And this is the outcome of our session. So first of all, real numbers are infinite. Okay, from 0 to minus infinity, and from 0 to again plus infinity 0. Okay, so we have infinite number of real numbers. So we can divide these real numbers into two separate groups. One is rational numbers, another is irrational numbers. Okay, so initially I told you that can you segregate these numbers into two groups? So here we have already segregated into two groups. One is rational, one is irrational. So w- I hope you all know group one is for integer, positive integer. Okay, one is for positive integer, and group two is for negative integers. Group two is for negative integers. And this is for fractional. This is for fraction or decimal numbers. So we can see that rational number consist of integer, positive integer, negative integer, and fractional and decimal numbers. Whereas irrational numbers doesn't have any such groups. But whatever that is not rational is irrational numbers. Okay, move on to the next slide. Okay, this is the main points. So what is rational numbers, or how we can describe rational numbers? We can describe rational number as a ratio of two integer. Suppose a is a rational number. A is a rational number. Then we can say a is p divided by q, where p is a positive integer, or p is a integer. I believe p is a integer. P is integer, and q is non-zero integer. Q is a non-zero integer. Okay, so here 3 is a whole number, and also it can be expressed as a 3 by 1. So that's why it is a 3 by 1. It's a it can be expressed as a p by q from, and 3 is a integer, 1 is a non-zero integer. That's why this is also a rational number. This is also rational number. Rational number. Okay, rational number. Also, 0.333, this is a decimal that repeating itself. So, this is also can be point 0.3, can be expressed as 3 by 9, 1 by 3. So this is also a fractional. This is can also be expressed as a ratio of two non-zero integer. Okay, so that's why this is also a rational number. Similarly, if we go on, then we will see 0.10 can be can be expressed as a ratio of two integer. -8 can also be expressed. 25% can also be expressed. That's why we can say these are all rational numbers. So what are rational numbers? Rational numbers are those numbers which can be expressed as a ratio of two integer. Then they are rational numbers. Okay. Then we move on to the irrational numbers. Which are irrational numbers? Irrational numbers are those numbers which are not rational numbers or cannot be expressed as a ratio of two positive integers. Okay, so that's our irrational numbers. So first of all, root 2, we will see root 2. Okay, root 2 root 2, if we evaluate the value of root 2, we will find 1.4 point something. Okay, and this will go on, and we will find out that it has non-repeating value, and it cannot be expressed in a fractional ratio or to integer ratio. That's why root 2 is a irrational numbers. Similarly, one more famous irrational number is pi. Pi is we you can say yes, pi can be expressed into 12 22 by 7, but that is not the real value of pi. For our computational easiness, we take pi value of pi as a 22 by 7. But actually, the value of pi is something like this: 3.14 point something something something. So this is a non-repeating decimals and non-terminating decimals. Okay, so it doesn't terminate. Okay, so that's why it's a irrational numbers. Okay, similarly we will find e as a irrational number, and the value of e is something like 2.71828. Okay, and this is non terminating. Okay, so I have forgot to give the value, but it's a non terminating. So now you need to find out what are the rational number and what are the irrational numbers. Like I have just doing it for one for you. Root 12 is a irrational number. So root 12 is the irrational numbers, and 5 is a rational number. So you need to do similarly, and just share the screenshot with me, and I'll tell who have done good. Okay. Now what how we need to plot these numbers on our number line. Okay, so first of all we will take a number line, and this number line generally start with 0, then 1 2 3 4 5, 1 2 3 4, is goes on something like infinity. Okay, goes on something like infinity. Similarly, it's 1, uh, -1, -2, -3, and goes on minus infinity. Okay. Okay. Now suppose if we want to plot a rational number like 2.5, we want to plot. So 2.5 is in between 2 and 3. So that's why we will plot this number between 2 and 3. Now if we want to plot suppose 1. 1 is also a rational number. We would plot on this number. Okay. Similarly, we need to plot irrational number as well. We first need to evaluate or approximate the value of that irrational number, and then using that, excuse me, using that approximate value, we need to plot that irrational number on the number line. So suppose root 1 2 root 1 2 equal to 3.464101. This is the value. This is the value. So if you look closely, it is in between 3 and 4. 3.4 is in between 4 and 3 and 4. Okay. in between 3 and 4. So that's why it is plotted between 3 and 4, and it is nearer to 3. Okay, if you see, it's less than 3.5. 3.5 is the middle of 3 and 4, and it is less than 3.5. So that's why it is little bit closer to 3 point, closer to 3. And again, one more irrational numbers is given 0.1434. It's not terminating and non repeating. That's why it's a irrational number, and we need to plot it on the number line. If we check this and try to plot this, we will see it is nearer to 0. Okay, nearer to 0, and it is in between 0. It is in between 0 and 1. It is in between 0 1, but it is very less than zero point 0.5. Zero point 0.5 is the middle. Suppose zero point 0.5 is this place. Okay, so it is less than zero point 0.5. So we have plotted this point 0.1434. Okay, I hope you have understood how to plot irrational numbers on a number line. Okay, so now I have given you one example. You have to plot these two irrational numbers on the number line. Previously, I have given the value of pi and e in my previous slides. So you need to check that, and you need to plot in this number line. Okay. I hope you all will share me the answer. Okay. Thank you. Thank you for supporting me. I hope we all will move like this and complete different chapters of math. Okay.